Okay, so hello for this session. So I'm Eric Cattoir. I'm working here in Belgium at IBM, and together with my colleague, who will present himself immediately, we will explain you how we did a prototype of an Internet of Things device based on Raspberry Pi and a number of other things which we will immediately explain, and how we used a number of solutions from IBM to implement that.
Hello, my name is Yves Debeer. I'm a colleague of Eric working in the IBM Software Group division. Working on mobile solutions and connectivity integration, API management. So we're going to start with the first overview of the solution.
Yeah, so we will first explain you what the purpose was, what did we develop, then we're going to explain you a bit what hardware did we use and what kind of components, and then we will show you a small demonstration of how the thing works. And then after that, we're going to dig more into the actual implementation. How did we implement both the software that's running on the device, the software that is running in the cloud at the server side, and also the mobile application that we developed to visualize what is happening on the device. So the first thing is, in fact, I was looking for an idea for building a demonstration of some of our cloud platform applications. And this summer I was walking in a museum and I was seeing that still in many museums they have these kind of devices which register like the temperature, the humidity, the whole day long, and then somebody walks around with his notebook, and every day or every half a day he notes down the values, and then probably somewhere they put that in Excel sheet or something of the sort. So I thought maybe this is something we can do, you can do better, so you can probably build something that automatically reads these values, collects these values, sends that to a service in the cloud, and then we also have some applications which, for example, could warn you when something is going wrong in a particular room, so that not somebody has to walk around all the time to check the values. So what did we use as a hardware? In fact, I decided to do this with a Raspberry Pi. So I used standard Raspberry Pi Model B, and then I used also a kit, and that was because I'm a bit lazy. I could also have been adding all kinds of sensors directly on my Raspberry Pi, but I found this neat kind of kit from a company called Tinkerforge, which is basically exactly giving me the sensors I needed. It was giving me a sensor to monitor temperature, humidity, air pressure, and luminance. So I used that kit, and one of the nice things with the kit is that they provide also really lots of APIs to access it. So I can use JavaScript APIs that they deliver to read the values. A few other things about which we will tell more also later in the presentation what we used. So on the Raspberry Pi we are running Node.js runtime, so to be able to use JavaScript on the Raspberry Pi, and there we used an IBM research project called Nodered, which is open source, available on the internet, which we will explain a little bit more later on, but it's basically based on Node.js, giving you a graphical environment to develop Internet of Things applications. And then on the server side, we used a solution from IBM called IBM Bluemix, and that is our platform as a service solution which runs in the IBM cloud. So that's where all our server stuff is running. And we will explain much more about this later on. Now, maybe first look at the solution, what is happening. So basically, here we have the device reading the sensor values, sending them to the cloud, and then my colleague Yves has developed this mobile application, which he will now show to you, so that you can see what the application is actually doing. So we are just projecting an Android phone on our screen, and there it's a quite basic application, but it will be enough to explain you what is happening. So we are looking at the rooms of the Louvre Museum. So our demonstration uses that museum as the example, and now we can click on a room. And then he retrieves the sensor data value. And now, for example, I could try to raise the temperature, etc., here in the room, but that's probably a bit difficult. But I can quite easily raise the luminance of my device or change the luminance value. So I'm now giving it a bit more light. And if then we refresh the values, you should see that the luminance goes up.
So if everything goes well, we get the new data directly from Bluemix, from the cloud.
So you see now we have a much higher luminance value coming out of the device. So let's now dig a little bit more in the solution and look at how is this all working, what are the internals. So the first kind of thing which I want to say a little bit about is the development environment that we used. In fact, we are using, with this Bluemix cloud comes something which we call DevOps as a service. So which gives you a lot of development capabilities in the cloud. So first of all, there is a web-based IDE, and that's the one which I used for my JavaScript code. If you're building more complex code, if you want to do Java, you might probably want to use a real IDE, but it is possible also to couple, for example, an Eclipse or another IDE to that same environment and make use of the services of that same environment. The environment provides you also with version control, change management, and all those kind of things based on multiple possibilities. It can either be Git-based, it can be based on Git hosted at GitHub, or Git hosted in the IBM cloud, or it can also be based on our own Jazz-based version management system. And on top of that, it also gives you a whole build chain, which is based on things like Jenkins and also a number of tools from the CloudFoundry open source product, because we will see that's what Bluemix is based on. So you can, in the cloud, just develop with a web browser. You develop in the cloud, your code is directly stored there. You can run your builds in the cloud, and you can deploy it on these Bluemix runtimes, about which we will speak a lot more later on. Next to that, there is a lot in this DevOps change. There is also a number of other services that you can use, like code scanning, security scanning of your code, and so on. So all these services are available. Let me, instead of looking here at the slides with the screenshots, I'm just going to quickly show you this environment. So I'm going to my browser. So here I have this environment with my project, with my museum climate monitoring project. And so I can just here look at the various pieces of code that I've been building. So let me maybe take some JavaScript code. I could edit all the code, etc. I have also all the tools here to see whether I made some changes, check in the changes. I can deploy from here to my cloud environment. I can even decide to deploy to multiple environments if I want to implement a dev, test, quality assurance, chain of systems. All these kind of things can be done directly from a browser, and also there is capabilities here to do agile planning, so I can plan all my iterations, divide the work to multiple people, collaborate with those people in that same kind of environment. So that allows you to start with really almost next to nothing. The only thing you need to be able to work on this is a browser and eventually an Eclipse environment if you would like to do so. So the next thing, so that was the development environment where we have been writing our code. Now let's look at the client implementation. So what did we do on this Raspberry Pi? How did we implement on the Raspberry Pi? And actually on the Raspberry Pi, we are using, as I said, a research project from IBM, so which is called Nodered. It's based on Node.js, so it runs on Node.js. So we first had to install Node.js on the Raspberry Pi and then deploy that environment on it. You access it through a browser, and then you will basically build your applications by tying together these nodes. And the nice thing about it is that this environment can be installed on lots of different hardware platforms, so it could also be done on Arduino. There is also support for BeagleBone, for the Intel Galileo devices. So you can deploy this on all these various devices, and in the same way build this kind of code. And there is also nodes which can interact with the hardware interfaces. So for example, for the Raspberry Pi, you can access the GPIO ports just by using some of these nodes. So if you want to work with this environment, you can just go to nodered.org. It's open source. You can download it from there. You can install it. You can also install it just on a regular PC. As long as you have a Node.js runtime environment that you can install on the machine, you can install the code on it. Now, let's take a look at the real environment running on my Raspberry Pi. So I'm going back to my browser. And actually, so this is running locally here on the Raspberry Pi. So I have here my development environment, and one of the things which I had to do to access my sensors and to be able to write on the display of this device was I had to build some of my own nodes. And we will immediately see that's quite easy. As long as you can access something from JavaScript code, you just have to write a JavaScript class, and that allows you then that you can deploy it then as a node in this environment. So I deployed this Tinker Sensors node, which is a node which will read the sensor values, and then I also deployed this Tinker Display node, which is gonna put information on the screen of my device. Now, I programmed two flows in this kind of environment. What are the two flows about? The first flow is a quite simple thing. Basically, what is it doing? It's getting the IP address just through an ifconfig command on the Raspberry Pi. It extracts from that the IP address, and then it will display that IP address on the display of my device. So why do I do that? For all these kind of occasions where I'm presenting here now, I plug my device into the network. I don't know what address it has. The screen tells me, and I can easily connect to it. So that's the only reason that I needed that flow. The second flow, what is the second flow doing? In fact, that is reading all these sensor values, and then it does two things with them. It first of all extracts the temperature string information from the four sensor values that come out of the device and sends that to the display. So that way I can show the information on the display. And then it also, with this node, it sends the information through an MQTT service into my cloud, and that's where then I can do something with that information. Yeah? Now we can also easily see what is happening. So here I have these debug nodes. These allow me to see what are the messages that flow here. So I see that here, once in a while, the device is sending the information into the MQTT. So it's just sending a JSON payload with the information, the timestamp, the device ID, the temperature, air pressure, luminance, and humidity into the queue. So that's how I programmed the client device. In fact, as you can see here, there is a lot of other in this node ret. There is a lot of other nodes. So I could, for example, very easily also send a tweet message with the temperature, or do some HTTP call with all kinds of things. So you can quite easily do a number of basic stuff in this node ret, and it's an environment. It's still under development, so there is, I think they are now at the version 0.9, but it's still evolving, and it's our research project directly geared at implementing Internet of Things solutions. So if you want to know more about it, or you want to experiment with it, go to this nodered.org. That's the site where you can download the thing, where you can find also documentation on how it works. And one of the things which we also want to do is share all these flows. If you build a flow and you think that's a nice thing which other people would be able to benefit from, there is also a community site where you can find lots of flows. For example, to be honest, the flow to read my IP address and show that on the screen, I basically found an example there, and I could more or less copy it. So just a few more things about this. So I build a number of custom nodes. How do you do that? You have to do two things. You have to write a piece of JavaScript. That JavaScript is doing all the work, so that's where you call in this case, for example, the APIs of my sensor device to read the values, or the APIs of my device to send information to the display. So that's nodes which I had to build. I also built one special node which you don't actually use, but is just to set up a connection with the device. So if you have something that requires a connection that you will keep alive for a longer time, you will typically implement also a configuration node. For each node, you write the JavaScript. You also have to write an HTML file that is just containing information on how the node will be visible on the screen. So there you will define what kind of icon your node gets, what the name is, how many inputs and outputs your node has, and so on. You define that in that HTML file. Here is some just quick example code of one of my nodes. So this is the display node which I made. So as you can see, you basically just have to create a constructor, so define a class for this node, and that can then do some simple JavaScript. And in this case, I'm just basing myself on the APIs that this Tinkerforge device delivers me, that allows me to connect to it and to send some information in it. So building this node is actually not rocket science, it's just some basic JavaScript programming, and as I had the APIs available, that was quite easy to implement. The flows, I'm not going to linger too long on the slide because I have been showing them to you already on the real demonstration. So let's then look at the server side. So now we have been looking at the device. So the device is using this MQTT node to send something into the cloud. How did we implement that one? So there we are using something which is called IBM Bluemix. So this is a cloud platform as a service that we are delivering, which is giving you a number of capabilities. First of all, it gives you a choice of runtimes. It gives you Java application server-based runtimes, Node.js runtimes, Ruby runtimes, PHP, and even you can also add your own runtimes in it if you would like to. Besides that, it will give you also a lot of services, and that's some of the things which we have been using also in the application. So it gives me services, again, to listen on an MQTT queue. So it provides me an MQTT broker and a service where I can connect to from my client device and send information. It provides me with a data service, NoSQL databases, and so on. So I can very easily just compose my application, add all these services, and then write some code in the chosen kind of runtime language. So in our case, we did that in Node.js, but that was just a choice. We could also have done it in Java or other, but we chose now Node.js to do this example. So a little bit more about the services. So there is a huge catalog with lots of different kind of services. We already mentioned the Internet of Things service, which we are using. We mentioned the mobile data service, where we're going to store the information which then the mobile app is going to read. There is also push notifications for mobile. There is also security services for mobile and other purposes. There is also big data implementations, data analytics, Hadoop is available there. There is also now, quite recently, we added a number of these cognitive computing services based on our Watson system. So all these services are available, and you can just compose your application with it. It is based on CloudFoundry, so we are using open source CloudFoundry platform for this solution, but we are beyond the basic things that the CloudFoundry is already delivering as an open source platform. We are adding a number of services, extending this with both our own services and a number of services from other vendors. So there is, for example, here on the conference, there is the people from Vaadin. They already have also some services which allow you to use their framework in our cloud platform. Yeah. So, and we are looking at more and more partners implementing those kind of things. Now, just from a usage viewpoint, how does that work? So the basic usage of most of the services is free. When you reach a certain usage, you will start to have a pay-per-use kind of model for the services. What is the idea? The idea is that somebody who has a nice idea, wants to start up, can do that with a very low entry point. You just need basically a PC with a browser, and you're good to go. You can start to build your application and to try out your idea. If your idea ever starts to take on, you become the next Uber or whatever, then you have this whole cloud behind you, which can scale, so your application can automatically scale. And then you will also start to pay for the usage of these services. So you will start to pay based on the volumes of messages that you send and all these kind of things. Now, to go back to our example, what did we use in our example? So we used the Internet of Things service, and in fact, that is an MQ telemetry transport broker, an IBM implementation of this thing as a service in this Bluemix cloud, and that offers us an easy publish subscribe messaging protocol, which works fine also over low bandwidth, unreliable kind of networks, because in many cases with these IoT solutions, you will have phone networks, etc., where maybe the bandwidth is not very good or is varying, you're not always connected and all these kind of things. So the MQTT provides support for messaging over these kind of networks. So that's one service which we are using. Now, if we look at the code for the server, you will see that this is also, again, quite simple, quite easy. So what did we do? We just we wrote the code in Node.js. So we used JavaScript libraries again. We used the JavaScript MQTT library to be able to connect. And then, in fact, the Bluemix gives us also a number of APIs which you can easily use to connect, for example, to this mobile data service. And in fact, to be honest, at this moment, we are writing the data in two kind of databases. We are using the mobile data service, and we are also using a Cloudant database. That was just because I wanted to experiment with both situations. And so what do? We have basically this MQTT listener code. So at first there is some code to initialize the connection and all those kind of things based on the values that came from the Bluemix environment. And then we have a message handler, which each time there is a message that comes in, will insert that message, in this case, in two kind of data stores. It inserts it once in the Cloudant NoSQL database, and it inserts it also in the mobile data service, which actually then Yves is using with his application to show us the information in the mobile application. So let me first, before we switch over to the mobile application, let me show you the Bluemix environment. So in fact, in the Bluemix environment, you define your applications, and this is my application which I have defined. So I have the museum climate monitoring application. I chose the Node.js runtime. And then I have been using a number of services. So I have been using the Cloudant service, the Internet of Things service, the mobile application security, which you mandatorily have to use when you use the mobile data. So I have also the mobile data and the mobile application security. And each of those give me also the information. So there is each time also the information on how to connect to it. So for example, if I look here at this show credentials, it will give me the information that I need in my code to access this service. And these are actually also environment variables that I can just access from my code. In fact, if I go back, I can make multiple applications. So I have a dashboard here with all my applications. So it's all demonstration applications. And then there is also the catalog of services. So here you see the various kind of services, and also boilerplates. So boilerplates are actually a combination of a runtime environment with multiple kind of services based for a particular kind of purpose. So for example, if you say, I want a Java web application, you could use the Java boilerplate there. If you want to do something Internet of Things, you could take the Internet of Things boilerplate, which immediately will already give you a Node.js runtime with a number of services combined. You can see also on the in the cloud side, we have deployed the Node-RED, so it's also possible to easily program with Node-RED on the side of the cloud. So we could use the same kind of Node-RED environment that we used on the Raspberry Pi. We could also use it on the server side to make our code on that side. And then obviously I also have lots of information about how is my application doing, how much memory is it using. So you can also control here on the dashboard how the application is behaving, what is happening, and all those things. So that basically ends the information about the server side, and then I will give the word to Yves, who will explain you a little bit now about how he created the mobile application to read the information and display it on a mobile device.
Okay, so we'll give you some more details on how I built this mobile application. To start up, there's a link available in Bluemix that you can access that already provides you a sample, the mobile data that you can download and start from there. This is also what I did to build this application. So in fact, it's a sort of to-do list application where you store the to-do items within the mobile data within Bluemix. So looking at the mobile data service that we have on an application, there are two things that we need to take into consideration is the URL, the route that we need to address the service in Bluemix. And then we also need an application ID and an application secret in order to call the API on this data service. You can also browse in the mobile data service to see what kind of information is in there. So in fact, it's a NoSQL database. We have sensor data as a collection available over there. And as you can see, it's all JSON data. So part of the D value over there, we have the separate values, timestamp, humidity, temperatures, and things like that. So we can already have a first look and maybe import some existing data right into Bluemix. The application itself contains, well, it's a very basic application. It contains two screens. The first screen is, in fact, the rooms is just a list of the rooms that we want to monitor. And then the second screen really gives you the detail on the sensor data that we have retrieved from our device. The application itself, there are some different components that we have used. So basically it's built on the Ionic framework. Also some AngularJS coding in there. It's also using Cordova, as well as the IBM Mobile Cloud Data Service, which allows us to connect to this mobile data service. So some parameters over there, you already see that the application ID, the secret, and the route that we need to configure in our application in order to access the mobile data. So it's all based on AngularJS, and this is the main app.js that we use within this application. So basically, if you're familiar with Ionic Angular, this is the main routing app.js that you will use in order to access the HTML pages of the application. So for example, the first screen lists rooms. This is the HTML template that we'll use to make up the screen of the rooms, and then the room detail, for example, will provide an HTML page to give you all those details. The app itself starts, of course, with an index.html page where we have all the JavaScript libraries that we need to use within our application. So Ionic is in there, AngularJS, the Bluemix JavaScript libraries in order to access the Bluemix environment. And of course, the app.js, the controllers and the services, part of the MVC framework that we use in Angular. And then at the bottom, you see one tag, the Ion Nav View, which allows you, in fact, to render the HTML templates to show up within your application. So to give some details on how this first page is built up, so the rooms, the list of the rooms that are available. First of all, you have the HTML template, which contains some Ionic statements and some Angular statements, like, for example, the ng repeat, which allows you to iterate over a scope, which in fact contains our room information. So it's very easy to build this kind of apps very quickly. And then the services that allow to build this list of rooms that contains, in fact, it's static data, so there are 4 rooms available in there with different IDs, and there are 2 functions on this factory service. In fact, so the all returns all the rooms, so you build up your scope that you can then use within the HTML to gather the information. And finally, within the controller, this is actually the controller that will be called and used for this HTML template, where you build up the rooms as part of the scope, and that will call up, in fact, the service in order to build this scope. Then for the second screen, where we present the sensor data, it's pretty similar, but we build up a list of items over there. So we really get the sensor data as JSON format. And then we present these 4 items just on the screen. It's very basic. But I did some order bys on these list items in order to get the latest data, because the data that is stored within the mobile data service is not really indexed. So we wanted to retrieve the latest data that we get from the sensors, so we order by timestamp, and we have limited here to 5 items. In fact, there are more than 7, I think. So really not to fill up the full display. You also see something which is very useful in Ionic, is to have the Ionic refresher tag, which allows you to really just pull down on the screen of the mobile application, and it will, on refresh, it will hit the on refresh JavaScript function. This is not showing very much. So part of the services that we need to initialize in order to get the Bluemix context, because we want to call up the mobile data services. First of all, there's a configuration where we get our definitions in bluelist.json. In fact, it's our app ID, our app secret, the parameters in order to connect to Bluemix. So this is part of the initialization process to call Bluemix services. And then there's a sensor data service, which will call out, in fact, to these mobile data services. And there we can use a standard NoSQL statements in order, in this case, it's a query find, where we will retrieve all the data that is stored within the collection in the mobile data service. So again, this will build up a scope that we can later on use within our HTML page to pull the data and show them on the screen. So that basically concludes about how the application is built. So it's very easy to take the SDK from Bluemix and use that within your application and call it out from basic JavaScript functions and really get those data into your application.
Okay, so to conclude the session, I have a few more things. So one of the things which we did is in the presentation. So if you download the PowerPoint presentation, you will also have the links to the various kind of things that we have been using. So which were, to recapitulate, which were the things we have been using? We have been using the Node-RED platform, which is this wiring development toolkit for geared towards IoT things, and you will definitely still see some evolutions there. If you want to follow that, you can see it on the nodered.org, or you could follow also the Twitter account Nodered, where they will publish all the latest updates and what is happening and so on. The other thing which we have been using, where there is also still a lot of things evolving, is this Internet of Things cloud. So we have been using the IBM Internet of Things cloud, and again, there is a link in the slide where you can go there. And there is again a Twitter account where you can follow information about that. In fact, there you will see still a lot of things also happening with regards to, for example, these low energy devices and how you access those and all those kind of things. And you can easily use it from the third thing which is mentioned here, our Bluemix platform. And the Bluemix platform is also a thing which is in constant evolution. Probably, if you look at the slides and the services that I had on the slide, and you will look at the real site, there is already quite a few more services available. So on a weekly basis, there is new services popping up there, and it's available to use. If you want to know more, or if you want to start using it, you can also come to our booth. We have there also free starter accounts where you can just sign up and try it out for yourself. And as you will see, it's really fairly easy. For building this kind of setup, we did it. It was not a lot of work to get these things going and play around with it. And then as a last point, I still wanted to mention, now in this case, we used a hybrid kind of application for the mobile, but we also have a lot of APIs which you can use from native development kits. So it's not because you say, okay, I'm building iOS native applications, or I'm building Android native applications, that you cannot use these cloud services. We also have developer kits which plug into Xcode, which plug into the Android development kit, and so on. So you can also quite easily build your native front ends and use these services, for example, push notification, etc., from this platform. So that is basically what we had to present here. I don't know if there is any questions still in the audience. Yeah, go ahead.
You have this Blueberry Pie there. Who is taking? I don't really understand who's talking to whom. Is Blueberry Pie sending a message to the server once in a while?
Yeah, so that's what's happening. In fact, there's Node-RED application on which we had. I can take it back. So let me go here. So actually, each time you see here in the debug screen a new message going, that message is being sent in through MQTT, so via this IoT cloud node, into on the server side. And on the server side, I just have a Node.js application which has a message handler which reacts each time there is a message that comes in and stores it in a database. So that's the setup.
So what when you're going to get new software into your Node.js to your Raspberry Pi, how do you distribute the software to that? Because when you have all these sensors out there.
Well, there could be, I don't have really a solution built for distributing the software here, but could be a lot of different things. For example, as we are using the Node.js runtime and also this Node-RED, you can use the NPM Node Package Manager to distribute new versions of your code to the devices also. And there is lots of other solutions also to manage. It's receiving the messages in a queue, and then you can write all kinds of applications that do something with those messages. And so the IoT service is providing you an MQTT broker, which allows you then to listen with various kind of applications and do something with those messages. So it's just providing you a transport protocol to the server side. Yeah? Any other questions?
I just wonder, I know that these flows are saved as JSON, as short as visual. If you get a more complicated flow, do you use any version control software? How do you do the version?
Well, at this moment, the Node-RED is just storing it in a JSON file. If you use the Node-RED in the Bluemix cloud, then it's storing those flows in a database. But they are indeed just these text files. I think that is one of the points where they are still, this is a research project, so that is one of the things where they are still looking at how to handle that. For example, I haven't been my nodes, I just put them there manually. In the most recent version, you can already use NPM to distribute nodes and add them to various environments. So that's things which are still in evolution. It's a research project, this thing. Okay. Okay, so then that concludes our session. So if you want to see more, if you want to look at the code, if you have more questions, come and see us at the booth. We are there with multiple people that know also a lot about these things and can show you some examples.
Thank you.